So today this machine decided to be malfunctioning, not working. Not sure what happened. So I'm just going to diagnose the circuit board. I checked AC power. There's AC. The fuse are okay, but the computer doesn't seem to be working. So don't know why. Just gonna disassemble it. Well, this is the circuit board. I know nothing about it. The part number is DA41-00838 alpha. Now, I could reverse engineer this darn thing, but I don't want to. So this is the 220 or 240 input AC, bridge, rectified. These are 500 volt caps, and then this is a switcher. This is a MOSFET, inductor, diodes to rectify the pulsed 350 volts DC. It's then regulated down to something. I'm not sure if it's 5 volts or 12 volts. So I did briefly check the diode. It seems to be shorted. However, because of the inductor, you can't really tell. So you have to take this apart to solder it and check if it's the diode is the problem. So I'm just gonna test the diode. I removed it from the circuit board, and so basically the tab is the cathode, and the anode, one leg. So that looks okay, although it's too low. Might be a Schottky. And then of course the other leg. So it looked like one leg is no good. It's shorted. And I have to look at the other side. Yep. So the diode is no good. Now what to do? Where do I get diodes? So the damaged diode is MBR 2100 Charlie Tango. So it's a 10 amps per diode, total 20 amps. Now, quite frankly, looking at the circuit board, I can't see it to be using 20 amps total. I mean, if you look at the trace, they are on a thick trace, capable of handling 20 amps. The trace would act like a fuse. So it has to be less than 10 amp each. It can't be total 20. And it's 100 volt diode. That is to say that the reverse voltage is 100 volts. And looking at the circuit board, the cap is 25 volts. So the diode, the switcher won't be outputting 100 volts. So and it's not going to be 10 amps. I guess what I'm saying is I have to figure out what to do, because I went to Roxas to see if I can get components, electronic components there. Well, you can't buy electronic components on Roxas or any shop close by, Kawayan or Santiago. So I have to compromise. I have to figure out, scavenge diode from other places. So I'm gonna look for a power supply, computer power supply to get diodes. I had these diodes, but they're not really meant for it. They're actually PVS or transferred. I was gonna experiment, but I'm risking burning the circuit board if I do that. So I have to look for other sources of diode. So I found this bridge in my bin. I don't know what it is, but it's a diode. And I'm just gonna finagle it into place like this. Bend the leads, and then test the circuit board. Hopefully it'll work. Actually, I wanted to find out what the output voltage is from this switcher. And if it works briefly and I know what the voltage is, I'm just gonna use a switching power supply to replace this switcher circuit board. I've soldered the bridge and then added a test cable so I can power it up. I really didn't do a good job. Really not the best, but oh well. Looks like there's a short. Doing this kind of whatever work, it's not really good. Mainly I don't have parts. Hard to get parts here in the Philippines or in Roxas. And I really need the refrigerator to work today, so I'm doing whatever. So I tested it and there is no output voltage, so it looked like this part is no good. I quickly checked this component from Lazada. It's between 6,000 to 7,000 peso. I really don't know what this part is. I know it's a MOSFET of some sort. And going through this to repair it, if I couldn't do anything about this, looked like I may have to buy it from Lazada. So I won't have any fridge for the next few days, a week or so, until I receive the part. October 13, around 7 o'clock in the morning. So I spent an hour or so looking for this board in the internet and on YouTube. So there are YouTube videos of this circuit board. They are in French or Spanish. From watching their action, not necessarily their language, I got a sense of what I should be looking for. Anyway, initially yesterday I did check for diode. So let me, I'm going to go through the power of this circuit board. So basically, this is a 220. This is the ACN 220. It goes through several common mode choke. I checked the fuse, and to see that the fuse are okay. Now this being a digital circuit board, they've designed it with a lot of common mode choke for noise suppression, EMI, RFI, that sort of thing. It's really critical if the circuit board is switching high voltage, because it will emit a lot of noise. So RFI EMI emission are suppressed by these common mode chokes and capacitors, of course. So to 240 here at home, the voltage is actually 250. It's not 220. It's 240, 250 volt AC. When this is rectified, when 250 is rectified, it's over 300 volts, 320. The 320 then is switched down. Basically, there's a 5 volt and 12 volt supply being generated by this step-down transformer. And this is the integrated switcher. It has MOSFET inside and the associated switching of the MOSFET, all integrated into this chip. Now, we bought a fridge 2018, so that's 2018, 19, 20, 21. You're looking at 4 years. So this thing has a maintenance plan of 4 years. So it doesn't last forever. If you're thinking that the fridge would last forever, they probably had a built-in design of 4 or 5 years, and then it needs to be repaired of some sort. Part of the plan, built-in obsolescence, buy a new fridge. So I wasn't interested in looking at the microcontroller or the circuitry. If I'm so inclined, I would probably reverse engineer this thing, but I'm not inclined. So the transformer, or the step-down transformer, is being switched by this dedicated IC. And this part is, it will output 12 volts from here, and also part of the transformer. It needs to be isolated. As you can see, these slots, that's high voltage isolation. So when you see slots like that, it's for a reason, isolating the low voltage from the high voltage. So you can see slots, or some sort of a dividing line, like there's a seepage and creepage, as they call it, when dealing with AC. So to deal with seepage, creepage, just put a slot. You don't want high voltage encroaching into the other high voltage. That's why they have slots. Like this 220, they created a slots to meet a certain requirement. So that's why there's slots here, to separate the two lines, creepage, seepage, and that's the reason why. So this will output, this leg, this is ground. This leg outputs at 12. This is another voltage. The diode, it goes into the regulator. So this provides a 5 volt 5 volt voltage. This is actually the feedback loop into the IC. It's feeding back by this optocoupler. So, which then the signal goes back into the IC. I believe it's TOP267. That's what I gathered from the YouTube. I haven't taken it apart yet to check out. The circuit board is labeled. There's a 5 volt label, a 12 volt label. So I was initially, when I was looking at this, I wasn't really paying attention, and only through looking at YouTube that I thought, oh, I should pay more attention to it. But typically, I jumped at it and thinking, I've done enough of these repairs, reverse engineering of circuit board, that I really don't care for the details. I just know that it didn't work. Why? Knowing I've designed these kind of things before, switcher, so I know how they work. So I jump at it looking for a voltage, and I realize, oh, there's no output voltage. Why? So I reverse engineer it briefly mentally. Check the diode. I'm always looking for a diode. So this is labeled. Let's see here. D. Huh? DD1. DD1, I guess. Diode. Why would they label DD1? Actually, it's labeled DIO1, so DIO1. So yeah, simple enough. Lots of inductors, noise suppression, that sort of thing. Here, coming from the 12 volts diode, you have this LC. This is noise suppression again. So the switcher power supply is not that complicated, but I need the fridge to be working today, so I'm gonna do something silly. Bypass the switcher. I'm gonna put in 12 volts external power supply. In order for that to work, I have to remove this part and take out this part. So I'm gonna do that. When you're repairing a circuit board and you've determined that, for example, this is the problem, you want to remove it from the circuit board, don't save it. Just cut the legs off like I did using a special tool. This is an old tool. I don't know how old, but it's probably 20 years. I hardly use it. First time I've used it in the Philippines. It was sitting on my toolbox for many years. It's rusted, and of course the tip is not working as it should be. There's a gap there, so when I'm cutting the leads, it's kind of difficult. So a bad part, you don't try to save it. It's already bad. Just cut the legs off. So the IC is actually cooked or fried. It released the silicon. Probably was smoke emitting IC. So there's the it popped its lid off. Now, one thing I find weird about this, the tag, which is that exposed metal, it's not being heat sunk. It should be heat sunk. It's deliberately inverted so that the tag is exposed to air. I question that type of design, because an exposed tag is supposed to be heat sunk by copper. For example, this is a phenolic cheap circuit board. It's a little bit complex because it is single-sided, and so a lot of tracks, traces. So this IC is purposely built for ease of design. As you can see, not a lot of jumpers, so the CAD or computer-aided design app that they're using probably did a lot of auto-route, or the guy is doing it so much that in his mind this is easy. So if I was doing this for many years, I would probably do the same thing and say, oh, easy, just a few jumpers. This kind of design, based on its complexity, would have taken the engineer, I don't know, 2 months, and then testing, going through RFI, testing, that sort of thing. Maybe this thing would have taken them 6 months to complete. There's a lot of engineering that goes into designing a circuit board like this, especially when it's single-sided. You have to think of it in your head. So, the reason why this circuit board failed is that failed and this failed. Now, the fact that this is shorted failed first before this blew its top, because it's going to switch a lot of current, and I'm somewhat surprised the fuse didn't take the failure. The fuse should have handled the failure before total failure came about. So something's wrong with the current specs. They allowed the fuse to survive. They allowed the two components to fail. I questions their design criteria, I suppose. Why allow two components to fail? It's easier to replace a fuse. Well, again, it's back to built-in obsolescence. So I've taken out the transformer, then the diode, and then the IC. So there's a burnt mark where the IC was. And so by taking out the transformer, I've isolated the high voltage, or any feedback loop. I've isolated it. So now I'm going to power it up with 12 volts. The again, cursory glance, it needs 5 and 12. And I know this is the 5 volts regulator. So to power up the logics, the 12 volts to power up something, solenoids or some other things. Not really interested in figuring out what it powers it up with, or powers up, what component it powers up. Probably powers up the relay of some sort, although it's within, oh, it's switching something. It's within the high voltage, so it's switching a high voltage component. This thing actually has a lot of options. Wi-Fi dongle. This was multi-purpose designed to handle different kind of fridge. It has a lot of headers, so it could be complicated. The things that you shouldn't do is wiggle these. It will break off the pads or tracks. Really, when you're wanting to fix this thing, just make sure the circuit board is not under stress. It could begin to give you a problem later. So I'm going to put in a 12 volts and jumper that 12 into this pads, and then this is ground. So I'm just going to check to make sure that is actually ground. But there's no other ground. Looking at this, looking at the pads and tracks, that is ground. That is the voltage for the regulator, 5-volt regulator, and that is the 12 volts. This pads right here, looking at after the diode and things, it looped back into the optocoupler transistor. So that's how it looped back the transistor, and then driving the optocoupler. It probably is using a pulse signal, PWM, proportional to output voltage, which drives the 5 volts. So this is the feedback loop. Nothing complicated about the switching power supply. I've ordered the parts again from Lazada, the top and the diode. The solution I'm doing might be permanent. However, just for video, YouTube, I will install the IC back, this and that, if it fails again later. I mean, it lasted 4 years, 5 years. 2018, late 2018, maybe Q4, Q3, Q4 2018. Now it's Q4 2022, so yeah, you're looking at like 4 years life. So when you buy a fridge here and you're out in the boonies, I call Roxas boonies because that's what it is, and you're looking for somebody repair it, I might go out to, I will probably check around Roxas, but I know from Lazada this is between 6,000 to under 8,000. So you're looking around $150 to $200. If you have it service, they might charge you less than 10,000 peso. It's around $250, something like that. Thinking Canadian, not US dollar. So that's a lot of money. If you have the wherewithal to actually repair this, do it to save you some funds. If you have other skill that you can utilize to get this working, great, use them. Otherwise, you're out of let's say $200 or 10,000 peso. So I'm going to use a switching power supply to do this. I'm going to bypass a lot of the noise emission control here. I need the fridge working today. And Nelia was asking, well, what are you going to do? Well, I'm going to do something silly. So I bypassed the damaged component with a power supply. So basically rewire this thing. You don't do this just for the sake of experiment and finding out how it's gonna work. Do it because you have a plan. I have a plan. Use a computer power supply. It's actually 12 volts, 3.3 amps. It should be sufficient to get this going. This might be a permanent solution. Depends. You know, I powered it up. So there is 5 volts here. As I suspected. I didn't even bother looking at the part number of the component. I suspected it's a regulator because I did a reverse circuit check. So this goes to the regulator. And this is the 5 volt regulator. I don't bother looking at the part number. It could be an LM7805, it could be something else. Having done enough of these type of circuit board, I don't bother checking the part number unless I'm really curious about the component. I'm not. All I know is that it gives you 5 volts. And because the power supply is 12 volts, then there is a 12 volts coming out of this jumper. So that's it. Now I'm gonna plug it in. I'm just gonna make sure the circuit, this thing is isolated using a heat shrink. Okay, I've connected the cables, heat shrunk it to protect against contacts. Oh, in the Philippines, there's a lot of rats. If you have lots of cables lying around and you don't touch them for years, rats will begin to eat at them. They know what the conductor or the cable. They love this kind of plastic. Just don't be surprised if you have box full of electronics and only to find out they're in the cables that you thought would be useful. Well, don't be surprised if you find them that they're no longer useful. I'm just gonna check the power supply again just to show you. So so you can see this jumper there is 5 volts, so it's 5 volts. And that jumper there is 12, so I got 12 and 5 volts. Now I'm gonna plug it into the fridge and see what happens. So it's all plugged back, all of the connectors. It's a good thing that the cables are not long. They're just cut properly. Sometimes it's difficult to figure out what happened, but you need to take a picture before and after. So this is the fridge off. So I'm just gonna power the logic and then the motor after. So I power up the logic. I'm gonna turn it off and then power up the logic after. Really vitally important to put in the 220. I'm actually powering up the logic with 110 or 120. So it seems like something is working now. The smell. Even not allowing the fridge to run for overnight, it has that smell already. So something is running. It'll take a while to cool down. But I just want to show you something. So let me just unplug it. 1001, 2. Get it power down for 10 seconds. Always to make sure the logic is actually off. So power it up. So all of these display, and then I hear a clicking sound. Relay is activating. And let's see here. Okay, the lights is actually on now. See, previous day I opened the fridge and the light was off, thinking, oh no, what did I do? So yeah, let's see if it. So basically the fridge is running on 220. The logic power supply is running on 110. And actually wait. So there's an LED here. It's used for diagnostic. It's solid red. So I'm gonna let it run and see what happened. I think the inverter power supply is fine. Only this part is no good. Just to warn you, doing this, you really get to know or understand circuits. So it all depends. Once the components are back from Lazada or are received or whatever. Can't remember the English word I want to use. But anyway, arrive from Lazada. Then I'm going to put the original component. But I'm gonna keep this because if this thing lasts 4 years, replacing the parts, some other parts probably will fail also. Between now and 4 years, who knows? This fridge may last 10 years. Something else will fail. The inverter board may fail. I'll have to check what the components are. I can buy these from Lazada, the components. The logic circuit board is between 6,000 to 7,000. I might order one just in case this thing will fail. I might. I probably will next year. But depending on how lazy I am, I might keep this for a while. Or depending on whether I'm really interested in showing how to install a component. That's boring. I might, just for views. Anyway, this is how I did it, bypassing the damaged component using a computer power supply, 12 volts, and that's it. Well, just follow up. The inverter is working. The condenser or whatever you call this is working. So yeah, okay. So the refrigerator has been running for over 3 hours, and the freezer is working. It's cold. So basically, I'm thinking maybe this is a permanent solution. Maybe, not sure. When the parts come from arrive from Lazada, I'll think about it again. Um, just thinking about it. So just a recap. The switcher driving the transformer is damaged. It's damaged because of the diode, the DIO1. This one, which is out, is failed to short or short. It failed and it shorted itself. So, and the moment it failed, there's a lot of current. I mean, 0 ohm. And the driving the transformer, it would also receive a lot of current. So it's sinking current quite a bit, and it has no choice but to blow itself apart. And of course it failed. Once it failed, it no longer provides 5 volts and 12 volts. So what I did, and this might be a short term, long term, depends, is study the circuit a little bit. I know that it needs 12 volts. It also needs 5 volts. I also know that it has a 5 volt regulator, so I simply need to provide it a 12 volts. So a single 12 volts will give 5 volts via regulator, and it just it's a make do. I really need the fridge to work. There's perishable goods, and without any fridge, those perishable goods will just go bad. And I did it out of expediency. If ever you have a Samsung fridge in the same failure mode, I don't really recommend this method. But out in the boonies and you're desperate and you have a power supply available, go for it. If you're not so inclined to take risk and say, well, if I do that, I could potentially damage the circuit board. Well, if the circuit board is already damaged, you will spend around 10,000 peso to get it done right. Here, I only spent some brain cells to figure this out, and a power supply that's lying around just to make this go. So I'm just gonna close this whole thing to protect it from the kids. They might want to touch it, so I'm just gonna close it. Maybe it'll just become a permanent solution. Maybe.